Problem A requires that we find g of 3, and g of 3 is the integral of the area under g prime of 3, or g prime of x, from 0 to 3 plus whatever g of 0 is. This happens to be an initial condition, so we're going to add our integral plus 5. So it's really asking, what is the area under the curve from 0 to 3? So it is all of this positive area this much is pi r squared over 4 because it's the quarter of a circle, and this is 1/2 a base of 1 and a height of 3. So this is 3/2. Our radius is 2, and 2 squared is 4. That 4 will cancel out, and this much will be just pi. And so g of 3 is then equal to our initial condition of 5 plus pi plus 3/2. Or if we find a common denominator, this would be 10/2 plus 3/2 plus pi, or 13/2 plus pi. That's g of 3. G of -2 would then be the integral from 0 to -2 plus, so this will be g prime of x dx, plus our initial condition of 5 again. However, it's hard to think about going from 0 to -2 backwards, so instead I thought of it as the opposite of -2 to 0 of our derivative plus 5. And so now we can just find the area going from -2 to 0, left to right like we're used to, and applying the opposite of that. So we would have negative, again, that pi, which we said this would also be pi, plus our initial condition of 5, or 5 minus pi. That is g of -2.